Yes, in the last class we discussed about the metallic conductors or electronic conductors and electrolytic conductors. The conducting property of the metallic conductor is due to the presence of free electrons or mobile electrons or the valence electrons which are present in the higher energy level of an atom. And the electrical property or conducting property of the electrolytic conductors, that is due to the presence of the charged particles present in the solution. Charged particles means ions, either positive or negative kinds of the ions that present in the solutions. Now what are the differences between the electronic conductors and electrolytic conductors? Very important differences between electronic conductors and electrolytic conductors. Electronic conductors and electrolytic conductors. Electronic conductors and electrolytic conductors. If suppose they ask the differences, then make two columns. Divide this into two, whereas the first one is electronic conductors or metallic conductors. Electronic conductors and electrolytic conductors. Electronic conductors and electrolytic conductors. First you have to write the definition. That's the first difference, that should be the definition. The conductivity is due to the movement of the electrons. Yesterday we discussed the conductivity. The conductivity is due to the movement of electrons. The conductivity is due to the movement of electrons. And here the first difference is the conductivity is due to the movement of charged particles. The conductivity is due to the movement of charged particles. Charged particles means ions. This is the first difference between the electronic conductors and electrolytic conductors. They conduct electricity in solid state. Metals, they conduct electricity in solid state. They conduct electricity in solid state. But electrolytic conductors, they conduct electricity in molten state or solution phase. They conduct electricity molten state or solution state. Sir, what is molten state and solution phase, or solution state and molten? Molten state means, for example, solid sodium chloride. Without adding water, When solid sodium chloride on heating, it gives the fluid mass. That fluid mass is called molten sodium chloride. Where is the solution is? Usually sodium chloride are inelectrolyte or water soluble one. When sodium chloride crystals are dissolved in water and the solution is called solution of the sodium chloride. That is called solution state. In solution state, solvent medium is there. In molten state, no solvent medium, only solid upon heating, then it gives rise to the molten state. Is it clear? Molten state. Now, third one. No chemical change takes place. 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 Here chemical change takes place. Chemical change takes place. Here the charged particles are there. Therefore, some sort of the chemical changes that occurs. That is a transformation of the charged particles. Here no chemical change. Here chemical change takes place. Chemical change takes place. Here it is a solid metal. Therefore, in solid state only they conduct electricity. Therefore, here the chemical change, because only metal is there, protons, neutrons and electrons are there. Therefore, chemical change will not occur. Here the positive, negative kind of the charged particles are there. Therefore, chemical change will occur. Chemical change will occurs. Is it clear? That is about the third one. Then next one, that is the fourth one. Conductivity decreases with the increase in temperature. Yesterday already discussed. Conductivity decreases with increase in temperature. Conductivity decreases with increase in temperature. This is decreases with the increase in temperature. Increase in temperature. Because its resistance increases. When temperature increases for the metals, resistance increases and conductance decreases. Here the difference is conductivity increases with increase in temperature. Conductivity increases with increase in temperature. Conductivity increases with increase in temperature. Conductivity decreases with the increase in temperature. Because increase in temperature, the mobility of the charged particles or the ions will increases, and hence momentum increases, kinetic energy also increases. Therefore, the conductivity also increases. Therefore, the conductivity that depends upon the movement of the particles. Therefore, the movement of the particles increases, and hence the conductivity also increases. This is with respect to the conductivity of the solutions. Metals do not decompose. Metallic compounds decomposes. Metals do not decomposes. Metals do not decomposes. Metals do not decomposes. Metals do not decomposes. Metallic compounds or electrolytes undergoes decomposition. Decompose. Metallic compounds undergoes decomposition. Metallic compounds means electrolytes. Electrolyte undergoes decomposition. Undergoes chemical decomposition. Undergoes chemical decomposition. undergoes chemical decomposition. Undergoes chemical decomposition. Then examples will be given. No transfer of matter takes place. Transfer of matter takes place in solution phase. Hope you written this one. Hope you written this one. This is the sixth one. Sixth difference. No transfer of matter takes place. No transfer of matter takes place. No transfer of matter takes place. But here, transfer of matter takes place. Takes place in solution phase. Transfer of matter takes place in solution phase. Solution phase. Example, metals. Metals, copper, aluminum, zinc, etc. Metallic compounds. Metallic compounds such as NaCl, KCl, copper sulfate, either in molten or solution phase. Either in molten or solution phase. Very important, solid substances that does not conduct electricity. Even though sodium chloride, copper sulfate, zinc sulfate, when these are the solid substances that does not conduct electricity, because in solid phase the rigid packing arrangement of the particles are there. There is no free space that is available for the movement of the charged particles, and hence that does not conduct electricity in solid phase. Solid sodium chloride, solid potassium chloride, solid copper sulfate, they are bad conductors of electricity. Only in molten state or in fused state or in solution phase, only chemical substances they conduct electricity. In solid phase they are rigidly packed. In solid phase they are rigidly packed. Therefore no space that is available for the movement of the charged particles. Is it clear? This is very important. Now my question is solid sodium chloride is a good conductor? No. Solid sodium chloride is not a good conductor. Only molten sodium chloride or fused sodium chloride or aqueous sodium chloride is a good conductor. This is about the important differences between the metallic conductors and electrolytic conductors. Now, what are electrolytes? In the last class we discussed about electrolytic solutions. Now what are electrolytes? These are the chemical substances like that of the sodium chloride, potassium chloride, copper sulfate, zinc sulfate, and organic compounds like formic acid, acetic acid, and amines, and even bases like sodium hydroxide, potassium hydroxide, ammonium hydroxide. These chemical substances are called electrolytes. What are electrolytes? They conduct electricity, whereas they have capacity to allow the passage of the current. They have capacity to allow the passage of current, and they undergoes ionization. Electrolytes, they undergoes ionization in aqueous medium. If suppose they undergoes complete ionization in aqueous medium, they are called as a strong electrolyte. If suppose they undergoes partial ionization in aqueous medium or in a solvent medium, they are called as a weak electrolytes. Now strong and weak electrolytes. They are further classified into strong electrolytes and weak electrolytes. That already you studied in first PUC ionic equilibrium chapter. Strong electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. What are electrolytes? What are electrolytes? Electrolytes. They based upon the degree of ionization. This classification based upon the degree of ionization. Classification based on degree of ionization. Classification based on degree of ionization. Degree of ionization means, what is the degree of ionization? Fraction of the electrolyte that undergoes ionization. Fraction of the electrolyte. Fraction of the electrolyte undergoes ionization. Undergoes ionization. Fraction of the electrolyte undergoes ionization per mole. Fraction of the electrolyte that undergoes ionization per mole is called as the degree of ionization. What do you mean by electrolytes? Electrolytes are the chemical substances. They undergo ionization in aqueous medium. In strong electrolytes, the degree of ionization is maximum. In weak electrolytes, the degree of ionization is minimum. Degree of ionization is minimum. Now come to the definitions of the terms. What do you mean by electrolytes? Non-electrolytes, electrolytes and non-electrolytes. Non-electrolytes that does not conduct electricity, means that does not undergo ionization reaction. Electrolytes. Chemical substances. These are chemical substances. Chemical substances undergoes ionization in aqueous or solvent medium. Aqueous or solvent medium. Chemical substances which undergoes ionization in aqueous medium. If ionization is complete, they are called strong electrolyte. Strong electrolytes these are almost completely ionized in their aqueous solution. These are almost undergoes complete ionization in aqueous medium. Complete ionization in aqueous medium. Complete ionization in aqueous medium. Aqueous solution. Complete ionization in solution phase. Aqueous solution or solution phase. Aqueous solution or solution phase. Solution phase. Example: strong acids, strong bases, and salts are derived from strong acids and strong bases. Salts derived from strong acids and strong bases. Strong acids and strong bases. strong acids and strong bases. Like that of HCl, H2SO4 or HNO3 or NaOH or KOH or NaCl or KCl or copper sulfate, etc. These are strong electrolytes. Now, what are weak electrolytes? Weak electrolytes, they ionize in aqueous solution to the smaller extent and have low degree of ionization. Their aqueous solution contains ions in equilibrium. They ionizes in aqueous solution. They ionizes in aqueous solution at smaller extent. The ionizes in aqueous solution at smaller extent. Their aqueous solution at equilibrium. Contains undissociated molecules. Their aqueous solution, smaller extent, and have low degree of ionization. Low degree of ionization. The ionizes in aqueous solution with a smaller extent and have low degree of ionization. Whatever degree of ionization that already mentioned, that is the fraction of the electrolyte that dissociates out of 1 mole in aqueous solution is called degree of ionization or degree of dissociation. Their aqueous solution contains at equilibrium with undissociated molecules. And degree of ionization increases with dilution. The degree of ionization of the weak electrolyte increases with dilution and approaches unity at infinite dilution. The degree of ionization of weak electrolytes. Increases with dilution and attains maximus unity at infinite dilution. Example: weak acids, weak bases, and salts obtained from weak acids and weak bases. What are weak acids? Organic acids like formic acid, acetic acid, and weak bases like ammonium hydroxide, and salts which are obtained from ammonium acetate, etc. Amines means NH2 containing organic compounds. Amines are good examples for weak acids, weak electrolytes. See, the ion is in aqueous solution to the smaller extent and have low degree of dissociation or degree of ionization. Means the extent of ionization of the weak electrolytes in solution phase is minimum. That does not undergo ionization to the maximum extent in the beginning. But when plenty of solvent is added, the degree of ionization that gradually increases. Means undissociated molecules that undergoes the dissociation by the addition of more and more quantity of the solvent. That is why the degree of ionization or the degree of dissociation that is increases with increase in dilution, that is a decrease in dilution, increase in the addition of the solvent, and acquires maximum at infinite dilution, that is a unity at infinite dilution. This is called Ostwald's dilution law. The degree of ionization of the weak electrolyte increases with dilution and attains maximum or unity at infinite dilution. This law is called as a Ostwald's dilution law. This law is called as a Ostwald's dilution law. This is very important law. This is very important law. In future they may ask in competitive exams, that is the degree of ionization of an electrolyte that increases with increase in dilution. This is at constant temperature. At constant temperature, the degree of ionization of the electrolyte increases with dilution, attains maximum to infinite dilution. This is called Ostwald's dilution law. Examples for weak electrolytes are weak acids or weak bases and salts obtained from weak acids and weak bases. You know that these are weak acids. Formic acid and acetic acid are weak acids. Then ammonium hydroxide is a weak base, and ammonium acetate or sodium acetate, they are obtained by means of sodium acetate also, ammonium acetate, ammonium formate, and all class of the amines, primary, secondary and tertiary amines, they are good examples for this weak electrolytes. Good examples for weak electrolytes. Now this is the basic term, that is resistance and conductance. What do you mean by resistance? Different chemical substances or different metals that offers resistance to the flow of the electrical charges through them. Whereas the metals are there, suppose the copper, silver, zinc, these are the metals are there. When you pass this current, then whenever the electric current is passed through them, different metals they offers different resistance to the flow of the current. The resistance is directly proportional to the length of the wire and inversely proportional to the area of cross section of the wire. Therefore, what is resistance? Resistance of a metal, resistance is the ability of the metal to oppose the flow of the current. Now, that is directly expressed by means of the ohms, and it is directly proportional to the length and inversely proportional to the area of cross section of the wire. Whereas the different substances offer resistance to the flow of the electrical charges. Substances offers resistance to the flow of charges. Resistance to the flow of charges. It is expressed in ohms. It is expressed in ohms. Substances offers resistance to the flow of the charges, flow of the charges or current, flow of the electrical charges or current, electrical charges, or you can call it a current. Different metals offers different resistance to the flow of the current. Resistance is directly proportional to resistance of a material is directly proportional to the length of the wire, directly proportional to the length of the wire, and inversely proportional to the area of cross section of the wire, and inversely proportional to the area of cross section of the wire, directly proportional to the length of the wire and inversely proportional to the area of cross section of the wire. Length of the wire is represented by small letter L, and area of cross section of the wire, it is represented by small letter A. Therefore, resistance is directly proportional to L, and resistance is directly inversely proportional to area of cross section of the wire, and hence R is directly proportional to L divided by A, or R is equal to rho into L divided by A, where rho is called specific resistance of the wire, where rho is equal to specific resistance of the wire, where rho is equal to specific resistance of the wire, Therefore, when L is equal to 1 and A is equal to 1, when L is equal to 1 and A is equal to 1, this means if the area of cross section of the wire is 1 square meter and length of the wire is 1 meter, then R is equal to rho. This is called specific resistivity of the material or specific resistance of the wire. Whereas a specific resistance is the resistance offered by unit length of the wire with unit area for the cross section. Whereas rho is called, specific resistance. Rho is called specific resistance. Now what is a specific resistance of the wire? Whereas R is equal to rho if and only if L is equal to 1 and A is equal to 1. Whereas the specific resistance of the wire is equal to resistance offered by the unit length of the wire with unit area of the cross section. Resistance offered by the wire whose length is equal to 1 meter and whose area of cross section is equal to 1 square meter, or unit length of the wire with unit area of the cross section. Unit length with unit area of the cross section. Unit length with unit area of cross section. Unit length with the unit area of cross section. Then R is equal to rho. R is equal to rho. Rho is equal to specific resistance of the wire. Is it clear? From this you can okay. Thank you.